All right, Unit 4, Day 2, Rational Function Graphs. So we're going to look at some terms that we've already seen before, but actually just write formal definitions. So the first one is x-intercept, where the function intersects the x-axis. And we know that this happens when y equals 0. So you should get this down in your notes. And remembering kind of what this looks like in your head. The next one is the y-intercept, where the function intersects the y-axis. And on the y-axis, that's when x equals 0. So you should also have this down in your notes. Notice how our x-axis, or our x-intercept is when y equals 0, and our y-intercept is when x equals 0. So I always kind of think of those, and I think of like doing the opposite thing. I also would look at that graph. So if I have just a coordinate plane, and I'm looking for when y equals 0, I would be looking on the x-axis because I got y equals 1, y equals 2, y equals 3, and on that axis is when y equals 0. So that would be my x-intercept. Then I look at my y-axis. That's where x is equal to 0. So remembering where those are located on a coordinate plane will be really helpful for you. So looking at those, which one is equal to 0? For the x and the y-intercept. The next term is vertical asymptotes. Now we've talked a little bit about vertical asymptotes before, but they are a vertical line that the function approaches but never touches. And how we figure this out is we set the denominator equal to 0. Now we'll actually show a question of how we get that. So let's look at this general function, y equals 1 over x. And we're going to do all three parts here. So we're going to find the intercepts and the vertical asymptote. And we know that 1 over x is x to the negative 1. We've seen this before. Those are the same thing. So let's find our x-intercept and our y-intercept. So remember, for your x-intercept, we start with y equaling 0. So we'd say 0 equals 1 over x. The only thing we know how to do here is multiply both sides by x. So we're going to do that first. Well, x times 0 is 0, and then the x's cancel out, so we get 0 equals 1. But does 0 actually equal 1? Nope, it doesn't. So we cross that out, and really then we don't have an x-intercept, so we just say no x-intercept. Now, either we have an x-intercept and we have that ordered pair, or we don't and we would say that it does not have one. Now let's find our y-intercept. So our y-intercept happens when x is equal to 0. So we'll set this up, y equals 1 over 0. Remember, when 0 is underneath the fraction, then it's undefined. So our y-intercept, really here, we get an undefined answer. So therefore, is there a y-intercept? No. So there's no y-intercept. And if you want to write out the whole word intercept, that's just fine. All right, next, let's find the actual vertical asymptote. So on this one, we know that we're setting the denominator equal to 0, because can we even divide by 0? Oh, also notice that instead of writing vertical asymptote, I'm going to refer to it as VA when I write it, just so I don't have to write as many words, because we're mathematicians. So for this one, I set my denominator equal to 0, and I'll get x equals 0. But I want to think about what the graph looks like also. So let's try to graph this function. And I'm going to graph my vertical asymptote also. Notice how we have a dashed line, and I moved it a little bit off of the axis just so you could see it, but it's that dashed blue line. That's our line x equals 0. And you've graphed functions like this before. Now, I'm going to write this in red so you don't necessarily have to put it down, but we're going to find specific points that go with this function so we can see how it's graphed. So I'm going to make a table. And you can do this in your notebook as well. I changed my mind. I'm going to start with different numbers there. I want to go from smallest to largest. So I'm actually going to start with -2, and then plugging in -1, -1/2, 0, and then the positives of those numbers, just so I can see what it looks like on both sides of that asymptote. So if I plug in -2, 1 over -2, we get -1/2. 1 divided by -1 is just -1. 1 divided by -1/2. Now this one's a little different. So we're going to write it out. Remember, we multiply then top and bottom by the reciprocal. So both of them times 2 over 1. And the bottom, those all cancel. So we end up with 1 times 2, which is 2, and then 1 over 1, which is 1. And that negative then belongs to the whole thing. So we get -2. -2. Good. Now if I plug in 0, I get 1 over 0, which we already saw was undefined. UND is kind of like an abbreviation we use for undefined. And then 1 over 1/2 is 2, 1 over 1 is 1, 1 over 2 is 1/2. Similar to how we already did that. So now let's graph this on our coordinate plane over there. And I'm going to use kind of a zoomed in level so that we can really see where these values are. So we'll plot -2 and -1/2. So remember that -1/2 is going to be halfway between 0 and -1. -1, -1 we'll plot. You should be plotting these with me now. And then -1/2, -2. Then we know that we have undefined, so we go to 1/2, 2. We go to 1, 1, and then 2 and 1/2. So we notice what this looks like, and it looks similar to something we've seen before, and so we're going to connect them. Now we've also talked before about extremes a little bit, but we're going to go into that more so in our next video. But notice how both of these ends, they approach that vertical asymptote, but they're never going to cross it. So, and we notice that there will probably be another asymptote-like shape on the other axis, but we'll get to that on our next one. So this is why our asymptote is x equals 0, because we get an undefined value there. So, and we don't have any intercepts because we are not crossing those axes. So let's try another one. Example 2. If I have y equals x plus 3 over x minus 4. All right, we're going to go through all of these steps again. So your job in class, for our next class, will be to do all of these, the x-intercept, the y-intercept, and the vertical asymptote. So x-intercept, we'll start the same way. We do 0 equals x plus 3 over x minus 4. The only thing we know is to multiply by the denominator. On the left side, x minus 4 times 0 is 0. The right side, those cancel out. We'll subtract our 3, so we'll get x equals -3. And make sure you write your answer as an ordered pair. Good. Then our y-intercept, we need that function again. So our y-intercept, we're going to find when x equals 0. So we'll say y equals 0 plus 3 over 0 minus 4. When we simplify that, we get 3 over -4. But really, at this point, now that negative doesn't belong just to the 4, but to the whole fraction. So when we write it as our ordered pair, we'll write 0, -3 over 4. So the negative is like out front with both the 3/4. The last part then is our vertical asymptote. So I'm just going to write it on the side here so you can see it. So this one, we set our denominator equal to 0 because we can't divide by 0. So when x is equal to, we add 4 to both sides. So when x is equal to 4, when we add 4 to both sides, when x is equal to 4, that is where our vertical asymptote is. So it would look like example 1, but it would just be shifted a little bit. And we'll look more at the graphs in class and as we keep going. But something we could start with is just plotting these things that we have so far. So I'm going to go over to use maybe 5 lines on each side just so that I can plot all of these. So I'm going to start and just figure out where each of these are. So I have -3, 0, that's my x-intercept. I have 0 and -3 fourths, which is going to be just above -1. And then I have the line x equals 4, which I'm going to draw as a dashed line. And we know that that's vertical, so we're going to draw that on the side. So there's more to this picture, but these are the first 3 parts of it. So even if you just have that little sketch there, that'll be really helpful as we keep going into more challenging questions. So let's try another example. What if we have y equals x squared minus 16 over x squared minus x minus 6. Now we're going to do the same process, but even though it looks a little more challenging. So the same steps. So we'll find our x-intercept first. And our x-intercept is when y equals 0. So we'll say 0 equals, and then the whole right side. And the only thing we really know how to do again is to multiply by that denominator. So I'm going to multiply both sides by the whole denominator. And when I multiply that by 0, anything times 0 is 0. So on the left side I'll get 0. On the right side they'll cancel out. So I'll end up with 0 equals x squared minus 16. And now I can just solve this because I don't have an x to the first term, so I can just solve this. I can add 16 to both sides. And then I remember, all right, so I have x squared. I have to take the square root, which the square root is the same as to the 1 over 2. And remember, when I have a square root, or I take the root and it's an even root, then I have to add that plus or minus. So I get plus or minus 4, and I'm going to write both of these. So I have 4, 0, and -4, 0 as my x-intercepts. So there are 2 different x-intercepts. Now let's find our y-intercept. So for our y-intercept, remember we set x equal to 0. So we're going to say y equals 0 squared minus 16 over 0 squared minus 0 minus 6. So every x is equal to 0. So the top we get 0 squared minus 16, which is -16. And on the bottom we get -6. A negative divided by a negative is a positive. Both of them are divisible by 2, so I get 8 over 3. And I'll write my answer as an ordered pair. X was 0 and y was 8/3. The last step we're going to do is find our vertical asymptote. So we go back and we know that we're going to set our denominator equal to 0. So x squared minus x minus 6 equals 0. On this one we'll have to do RS. So we do -6 on top, -1 on bottom, what multiplies and what adds. And we're thinking, oh, -3 and +2. So we remember -3 times 2, we get -6, -3 plus 2, we get -1. So I'm going to expand that middle term, and then I'll do my left side, right side. So I get x times x minus 3 plus 2 times x minus 3 equals 0. And notice how both of those are the same in the middle. So I get x plus 2 times x minus 3 equals 0. Notice how these are the same as the r and the s that I found earlier. So if your leading coefficient is 1, then you could just jump right to this step. But only when your leading coefficient is 1. So then we're going to set each of these factors equal to 0, and we'll solve. So we get the equation x equals -2 and x equals 3, and those are both of our vertical asymptotes. So on this one we have 2 vertical asymptotes. Thank you for watching. We'll see you soon.